Hi guys, welcome to the channel. So in the previous video we were discussing some of these examples in which we were uh, trying to understand the conversions of the hydrocarbons. So now we are going to discuss when the molecular formula contains non-carbon or hydrogen elements, then what happens. In that case the ratio of carbon to hydrogen changes. So now the next question is how we are going to predict the molecular formula in that case. So we are going to discuss these three rules one by one. So rule number 1 is when we have an open chain saturated hydrocarbon and we want to change this open chain saturated hydrocarbon to a formula having group 5 elements. So group 5 elements are what? Nitrogen, phosphorus, arsenic, antimony, bismuth. These are group 5 elements. So suppose we have an open chain saturated hydrocarbon and now we want to change it to a formula which is having group 5 element. In that case, add one hydrogen atom to the molecular formula. So for example, if we are having C2H6. So if we want to add any group 5 element, then we are going to change this particular formula to C2H7N. Here we have added one hydrogen and we have added one group 5 element. Or other example could be C2H8N2 if we want to add two nitrogen atoms. Also C2H9N3 if we want to add 3 nitrogen atoms and so on. So this is the first example if we have an open chain saturated hydrocarbon, right? So this is having formula CnH2n plus 2. In that case, if we want to add group 5 element, then we are going to add one hydrogen atom and we can add one group 5 element with that. Now with that, moving to rule number 2, that is if we have an open chain saturated hydrocarbon and we want to add group 6 element. So group 6 elements are oxygen, sulfur, selenium, tellurium. If we want to add any of these atoms, so there will be no change in the hydrogen number required. No change required. So for example, if we have again C2H6, we can simply add any of these group elements like C2H6O, C2H6O2, etc. No changes required. Now with that, moving on to rule number 3. So again, if we have some open chain saturated hydrocarbon and we want to add group 7 element, group 7 elements are fluorine, chlorine, bromine, iodine. In that case, subtract one hydrogen atom to the molecular formula. For example, again if we have C2H6, then it will change to C2H5F or C2H4F2, etc. So these are the three rules if we want to add any of the group 5, group 6 or group 7 elements. So if we want to add group 5 elements, just add one hydrogen atom and you can add one group 5 element. For group 6 elements, you need not change the molecular formula. You can just add any of these elements in any number. Now next third is if we have open chain saturated hydrocarbon and we want to add group 7 element, just subtract one hydrogen atom and add one of these elements. So these are the three rules. Now we will move on to the main part, which is the unsaturation index or the index of hydrogen deficiency. So now we are going to discuss the formula for that. So now we will discuss So now we are going to discuss about unsaturation index or index of hydrogen deficiency. For that you have to compare the molecular formula with the corresponding acyclic saturated formula. So when you are going to compare the molecular formula with its corresponding acyclic saturated formula, there will be some difference of hydrogen atoms. So there will be some difference in the number of hydrogens. Just divide that difference in number of hydrogens by 2 and that will be the unsaturation index. So we will quickly discuss one very simple example. We are going to discuss this in an elaborate manner also, but now we are going to discuss a very small example. So suppose if we have C3H6, this is some molecular formula. So if we compare this with CnH2n plus 2, so here n is equals to 3, right? Now this is the molecular formula, and now we are going to convert this to the corresponding acyclic saturated formula, which is this one. So here if we compare C3 with Cn, then n is equals to 3, but if we substitute the value of n is equals to 3 here, then it is not going to be equals to 6, it is going to be equal to what? It is going to be equal to 8. So in this formula, from here if we are going to compare this value and this value, we are going to get 3. Put that value of 3 over here and you will get a formula. If we have CnH2n plus 2 and if we have n is equals to 3 from here, so you will get C3H8. So for C3H6, the corresponding acyclic saturated formula is C3H8. From where we have got that? From this general formula of acyclic saturated compounds, right? So if we substitute 3, then we will get saturated formula as this one. So if we compare this formula with this formula, there is difference in number of hydrogen atoms. So there is difference of 2 hydrogens. So divide the difference in number of hydrogens by 2, you will get unsaturation index. In that case, unsaturation index is 1. Now this is a very basic example. In the next video, we are first going to discuss why we need to study this unsaturation index, and then after we will discuss in elaborate way what are the steps to determine the unsaturation index. This was a very small example. We are going to discuss in an elaborate manner. After that, we will go on to rule of 13, and then after I want to discuss some of the topics, some of the more topics which I want to add up in this particular series. We will go on to doing those topics as well. So far that's it for this video. I hope this video was helpful for you. So thank you so much for watching.